Okay, welcome back to another lesson in AP Calculus. We're in Unit 7, and Unit 7 is all about the indefinite and the definite integral. Today we'll be looking at the definite integral, but we'll be looking at some that require us to use our algebraic use substitutions that we talked about earlier. So let's take a look at this one. We're going to evaluate this, so we know that we need to find the antiderivative, but this is not easily done. It's got a multiplication and all that. So you should be thinking, okay, I need a u substitution. And it turns out that the previous lesson we avoided u substitution, but that's because we handpicked questions. Most of them are going to require it. Not all, but most. So I'll let u be the thing in the middle. That makes du equal 2x dx, which makes us say 1/2 du is x dx. And now I've got it just the way I want it. So I'll bring out the 1/2, rewrite my integral, and I'm going to come back to what goes here and here. X squared plus 1 is u, so that's a u cubed. And x dx became the 1/2 du. I brought out the 1/2, so this is just a du. Well, these bounds are bounds for x. They're not bounds for u. So I need to change these bounds. And since u is equal to x squared plus 1, if x equals 1 is my lower bound for u, when I plug in 1 to x, is 2. And my upper bound of 2 becomes a 5. And you need to do that. You're allowed to just actually leave them off if you want to do all the u substitution work and come back. But we don't want to do that. We want to change the bounds and do it properly. But if it's a free response question and you don't change these numbers, you will get points off because that's inconsistent. All right, now let's integrate. This becomes u to the 4th over 4. And I don't need a plus c. And we're going from 2 to 5. Now at this point you may be thinking, okay, now I got to change my bounds. I got to change my u back to the x squared plus 1 and then change my bounds back. Well, I could do that and it'd get me the right answer. But I don't have to because I can just use my u. So it's 1/2 5 to the 4th over 4 minus 2 to the 4th over 4. And I'm not going to figure out what 5 to the 4th is. I guess it's 625. So it's like 625 minus 16 all over 2. But we're just going to call that our answer. All right, let's try this next one. All right, we're going to let u equal 1 plus the natural log of x. So then du is equal to the derivative of natural log of x is 1 over x dx. So that makes this become the integral from, let's plug in 1. The natural log of 1 is 0, so this 1 stays the same. Then the natural log of e is 1, and 1 plus 1 is 2. And then x dx became just du, and 1 plus the natural log of x is u. So this is just u to the 3rd. So we end up with u to the 4th over 4, which we'll evaluate from 1 to 2. 2 to the 4th is 16 over 4 is 4, minus 1 to the 4th is 1 over 4, so I'll just call that 3 3/4. All right, let's take a look at the next one. We've got a little sign inside a cube, so let's let u equal the sine of x, so that du is equal to cosine of x dx. So that's actually just works out perfect. So u is sine of x, so plug in 0 for x. The sine of 0 is 0. Plug in pi over 6 for x. The sine of pi over 6 is 1/2. So we're integrating from 0 to 1/2 of u cubed du, which gives us u to the 4th over 4, which we'll evaluate from 0 to 1/2. And this one's kind of ugly, but one thing we can do is we can bring out that 1/4, and then it's just u to the 4th from 0 to 1/2. And when you raise a fraction to a power, you just apply the power to the top and a power to the bottom. So it becomes 1 over 2 to the 4th is 16. So this is just 1 over 64. Of course, you don't, if it's free response, you know you don't usually have to simplify. Okay, let's try the next ones. I want you to do these practice problems A, B, C. So pause the video and then we will go over them. All right, let's go over this one. All right, hopefully you chose to make u 1 plus 2x squared, which makes du 4x dx. So we'll call this 1/4 du is x dx. So this becomes the integral. I'll plug in 0 for x. It gives me 1. 2 for x gives me, 9, I believe. And then the 1/4 du takes out the x dx. This is 1 over the square root of u du. We'll go ahead and rewrite that as u to the negative 1/2 du. Then we'll integrate. We get u to the positive 1/2 times 2. Don't forget that 1/4 on the outside, and we're going to go from 1 to 9. I can pull the 2 out, making this a 1/2. And then just do that. We'll plug in 9 to the 1/2 is 3. 1 to the 1/2 is 1. Subtract them. So the answer is 1. All right, let's try the next one. Let u equal 3x, so that du is 1/3 dx, making this the integral of 1/3 sine of u du. And if I plug in pi over 12 for x here, pi over 12 times 3 becomes pi over 4. And pi over 9 times 3 becomes pi over 3. We integrate, we get cosine of u, but when we get cosine, it's negative. And we'll be doing that from pi over 4 to pi over 3. And don't forget the 1/3. And I'm just going to bring that negative out like that. So this is a negative 1/3 times the cosine of pi over 3 is 1/2. The cosine of pi over 4 is the square root of 2 over 2. And I'm just going to leave it like that. Note that this would be a positive number, though, because root 2 over 2 is bigger than half, but times a negative on the outside gives me so it become a negative times a negative. All right, let's take a look at this one. We're going to let u equal 2x minus 1. So du equals 2 dx. But unfortunately, I have an x, right? So I'm going to go ahead and make this 1/2 du equals dx. But then I'm going to solve this top one for u, make it for x, make it u plus 1 over 2 equals x. So then this becomes with a 1/2 on the outside. 1, we've got to plug in 1 for our u equation. 2 times 1 minus 1 is 1. 5 times 2 is 10, minus 1 is 9. X dx is going to become, the x is going to become u plus 1 over 2. The 2x minus 1 is u, so this is times the square root of u, and it's on the bottom with the 2. And then dx became 1/2 du, and I already brought that 1/2 out over here. I'll bring the 2 out from the bottom as well. It's on the bottom, so it goes on the bottom and multiplies to become 1/4. The integral from 1 to 9, and this is u plus 1 over u to the 1/2 du, which gives me 1/4 times the integral from 1 to 9 of u to the 1/2 plus u to the negative 1/2 du. All right, we'll go ahead and integrate. I'll bring it over here. 1/4. This is u to the 3/2 times 2/3 plus u to the 1/2 times 2, evaluated from 1 to 9. Again, I'm going to bring these 2's out. I'm going to factor these 2's out, making this a 1/2. And then 1/3 u to the 3/2 plus u to the 1/2. So sometimes I like to do that. Get rid of all those constants. Let's plug in 9. 9 to the 3/2. Well, the square root of 9, that's the 2 on the bottom. Let's do that first. The square root of 9 is 3. 3 cubed is 27, but over 3 is 9. And then 9 to the 1/2 is 3. Now I'll plug in the 1. So this will become 1/3 plus 1, and I put those in parentheses. So 9 plus 3 is 12. So this becomes 12 minus 1 is 11 minus 1/3, so 12, I'll just do it this way. 12 minus 1/3 minus 1. So 12 is 36 over 3. Minus 1 over 3 is 35 over 3. Minus 3 over 3 is 32 over 3, making this 16 over 3. All right, let's go and look at the next one. It says, suppose the integral from 4 to 1 of f of x dx is equal to 8. Find the integral from negative 2 to 1 of f of x plus 3 dx. Show the steps leading to your answer. Well, what we need to do here is actually a u substitution. Since we don't have the equation for f, we can't really simplify this any. So I have to let u equal x plus 3, which makes du equal dx. So we'll do our substitution. Negative 2 plus 3 is 1. 1 plus 3 is 4. And then this is f of u du. So this one actually turns out to be exactly what it has. Quite often, though, there's usually an extra multiple or something like that you have to handle. But this is just 8. So there we go, which, I think makes sense. I don't know what the shape of f was. From 1 to 4, maybe f looked like that, okay? But if I graph f of x plus 3, if you remember your transformations, that's just going to shift everything over by 3. So now it's going to go from negative 2 to 1. But it's the exact same shape, so it's the same area. It's just been scooted over, and so did our bounds. All right. Use the graph of f of x shown below to evaluate the integral from 2 to 5 of f of 2x minus 4 dx. Show the steps that lead to your answer. Pause the video and give it a try. All right, let's see how you did. You should do a u substitution. U equals 2x minus 4. So then du equals 2 dx, which is 1/2 du equals dx. So I'm going to change this as the integral from, if I plug a 2 in, I get 4 minus 4 is 0. If I plug a 5 in, I get 10 minus 4 is 6. I'll bring the 1/2 out, and this becomes f of u du. So this is the graph of f. We're going to use it. We're going to go from 0 to 6. So from 0 to 1, we have an area of 1. That's 1/2 times 1 times 2 is 1. So we have an area of 1. Then the next area is going to be negative, and this is a width of 6. This is a triangle with a width of 6. Oh, you know what? I just realized something. We are not going to 6, though. We are only going to... Are we? No, we're going to 6 because we did 2 times 5 is 10. We're going to 6. So that's not right, though. I should only go there. Okay, so this is actually a little bit different. How would I do that? Well, there's lots of different things we could do. I think what I'll do is break this up like this and make this 2 times 1, 2, 3, 4 is 8. Half of that is 4. And then this area here is 1, 2, 3. So minus another 3. And then this area here is 3 times 3 is 9 over 2. And so whatever that ends up being, that's going to be our answer. I'll let you do the arithmetic. I probably meant for this to go all the way to 7 and probably miscounted on my line. But oh well. Let's see here. Find the area bound by the graph of y equals x times the square root of x squared plus 1 and the x-axis from 0 to 2. Pause the video, give it a try. All right, hopefully you remember that the area is a definite integral. From 0 to 2, this is all above the x-axis, so we just need to use the integral from 0 to 2. We don't need to take any absolute values. Make sure you put your dx. We'll let u equal x squared plus 1, so du equals 2x dx, which tells me that 1/2 du equals x dx. So this is the integral from 0. Oh, not from 0. 0 squared is 0, but plus 1, so 1. Then 2 squared is 4, plus 1 is 5. And we're going to bring the 1/2 out here. And I'm just going to call this u to the 1/2. And then x dx became my du. So we integrate here. We got u to the 3/2 times 2/3, which we're going to do from 1 to 5. I'll bring that out because we 1/3. And I'll go ahead and plug in here. 5 to the 3/2 minus 1 to the 3/2. I brought out the 2/3 and the 1/2, which is why I have a 1/3 on the outside. So, and I think that's simplified enough there. All right. The function y equals this x times the square root of x squared plus 1 graphed in the previous practice problem is called an odd function. It has odd symmetry. Without doing any calculus work, what is the area between the x-axis and the function from the interval from -2 to 0? Well, from -2 to 0, it's going to have the exact same area. It's negative on the integral, though, but it's going to have to be the same area. So we can just say, what is the area? Well, the area is just 1/3, 5 to the 3/2 minus 1, because they're symmetric. So how does that relate to that? The integral from 0 to 2, well, the areas are the same, but they're opposite signs. So the integral from 0 to 2 of x times the square root of x squared plus 1 dx, ooh, I forgot my dx's. How bad. I was just warning y'all not to. Is equal to negative the integral from -2 to 0 of x times the square root of x squared plus 1, because they are odd. They have origin symmetry. All right. Water is being pumped into a tank at a given rate r of t. A table of values for r of t is given below. Use the data from the table and 4 subintervals to find a left Riemann sum to approximate the integral from 0 to 20 of r of t. Use proper units and explain the meaning of your answer. So the integral from 0 to 20 of r of t dt is approximately equal to (5) is the base of the first interval. We're using a left endpoint, so plus 14. Then 4 times 18. And then that's what? 9 to 15 is 6 times 20. And then 5 times 27. Now the units. Well, this 5 is a change in minutes. So this is in minutes, and this is in gallons per minute because it's a rate. So 5 times 14 gallons per minute, 5 minutes times 14 gallons per minute will be just gallons. So this whole thing is going to be in terms of gallons. And we could simplify it, but we don't have to if it's a free response. So what does this mean? That means that after 20 minutes, and, well, just to make the sentence more readable, I will go ahead and evaluate that. 5 times 14 plus 4 times 18 plus 120 plus 5 times 27. But under no circumstances should you. You should just say this is, or write it out again, 300, after 20 minutes, 397 gallons has flowed, or been pumped into the tank. All right, next let's use a right Riemann sum. So we're going to do the integral from 0 to 20 of r of t dt. So that's going to be equal to 5 times 18 this time, plus 4 times 20, plus 6 times 27, plus 5 times 32. And again, the units is in gallons. And that's it for this lesson, so I'll see you in the next one.